dear aspirants of 9th standard, in previous class I taught you the chapter 8 motion, and just I explained the terms whatever it is given. Furthermore, these points I taught you earlier in the 2 days, and just I complete this chapter today. Okay, so whatever the terms, just we will have to do here. Few questions are given. An object, I taught you earlier that an object has moved through a distance. Can it have zero displacement? I explained this earlier. It has it will have zero displacement, because in such a case, see here, suppose this question, whatever I taught you earlier, it is written here for 9th standard motion. Okay, in 9th standard, just I prepare all the topics in science, mathematics, as well as other subjects also on this channel through, and just I do want to teach the aspirants so that they will never face any problem while going through the chapter. Now see, whatever still we learn, questions are based upon those only. The first question, how can we do an object has moved through a distance? Suppose an object moves through a distance. Initially, the object was at a point. Now, after some time, it is at the B point. Correct? So, the question states that, can it have zero displacement? Naturally, if the object will change its position from A to B, and again it will return to the point A, naturally here distance, suppose it is 5 meter. The distance from A to B is 5 meter. So distance covered, in this case, distance will be how much? 5 meter in this direction, again 5 meter, because object reaches at the initial point finally. Distance equal to 5 meter plus 5 meter. Distance will be how much? 10 meter. But if we will have to calculate here displacement, naturally its displacement will be zero, because displacement is a vector quantity, and in this direction it will be 5 meter, and when the object moves in opposite direction the same distance, naturally it will be minus 5, so resultant will be how much? 0. So in this case displacement will be 0. Now see, in second, a farmer moves along the boundary of a square field. See here, in second question, a farmer has a field, a square in shape. Okay, means 10 meter is its boundary or outer portion of the field, correct? 10 meter, like this, and just he walks on it through this. What is the 10 meter in 40 seconds? A square of this side 10 meter in 40 seconds. Farmer moves along the boundary. That means suppose if farmer starts from here, in 40 minutes he covers, okay, the complete. What will be the magnitude of displacement of the farmer at the end of 2 minutes, 20 seconds from its initial position? 2 minutes, 20 seconds. We have to calculate what the distance it will cover. Now see, because the side of the field is 10 meter, okay, naturally its perimeter will be how much? Its perimeter will be how much? 4 into side, then it will be how much? 40 meter. That means when the farmer starts from this place, he covers 40 meter in 40 seconds. That means distance covered in 1 second is how much? Distance covered in 1 second in 1 second. It is how much? 40 by 40, that's equal to 1 meter. Okay. Now we have to calculate the displacement in which time? 2 minutes 20 seconds. Now see here, time will be how much? Total time given equal to how much here? Given equal to 2 minutes 20 seconds. 2 minutes 20 seconds. 2 minutes will be how much? 120 seconds plus 20 means 140 seconds it is. Now just we will have to calculate here that in 140 seconds how many rounds it will cover, because in 1 second it covers 1 meter. That means in 40 seconds, in short, just we have to find out here, in 40 seconds it covers 40. That means in 1 second it covers 1 meter. So in 140 seconds it will cover, distance covered equal to how much here? 140 meter. Now see, 1 round it will cover 40. Now 140 into equal to how much? 40 into 3. Now see here, 40 into 3 plus 20. That means the farmer will move 3 rounds and it will cover 120 meter. Now extra 20 meter, just it covers, means it covers 10 and 10, 20. That means now in 4th round, the farmer is from the initial point, it is here. He is here. Okay. Now naturally its displacement will be equal to its diagonal. The displacement from the initial to the reaching point is this diagonal. So diagonal will give its, so diagonal will be how much? As you know, that diagonal equal to root 2 into side. Naturally it is root 2 into 10 meter. So displacement will be how much? The value of root 2 is 1.414. Put here. Now its answer will be 14.14 meter, exact answer. So in such a way, how can we decide? See here, just we find that in 1 second he covers 1 meter. Now total time is given 140. That means in 140 it will cover 140 meter. So farmer starts from here and reaching to that very point, he covers 40. That is why I think that how many round it will cover? Naturally it will cover 120 meter in 3 rounds. Means 1 round, 2 round and in 3 round. Now in 4th round he moves 20 meter. Naturally his position is here. And what will be the displacement? Because this will be the distance. 20 meter will be the distance covered by at the initial point, from the initial point to the final point. But here distance will be how much? Displacement will be how much? This will be the equal to, just you have to mention here, displacement equal to diagonal of the square field, just we have to mention here, and similarly we can find the answer. Now just I move on the next point, uniform motion and non-uniform motion. Okay, the definition of uniform motion is that if any object covers, okay, which chapter just I am teaching you? Motion for 9th standard. Okay, 9th standard motion chapter just I teach at present. Now see here, uniform and non-uniform motion and non-uniform motion. Just I tell you the definition of uniform motion. If an object covers equal distance in equal interval of time, then the object is said to be in uniform motion. And if the object does not cover equal distance in equal interval of time, then it is called in non-uniform motion. Then it means that object or a body is called in non-uniform motion. So according to diagram or according to the concept, graphical concept, how can we show that it is uniform motion, it is non-uniform motion? See here, because there is question of motion, so naturally motion is related with speed or velocity, and as we know that speed equal to how much? Distance by time. It is the formula. In mathematics also you study about this in junior classes. Now see, that means we have to take distance on the one axis of the graph and time on the other. See here, just I have taken time in second and distance in meter on y-axis. Distance in meter. Okay, and here this is the origin. Okay, now see, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, up to like we consider here on the x-axis. And here the distance covered is 10 meter, 20 meter, 30 meter. At the interval of 10 we consider here. Correct? Whatever the interval we will take, that will be the presentation of the graph only. Now see here, if the object covers in 1 second, it covers 10 meter, then what will be the meeting point of the graph? If we will plot it, naturally it will come here, because this point will come and it will coincide here. Now in 10 seconds, if it covers 20, in third second it covers 30, means whatever the graph is here, it gives a straight line. Then it is said that the motion of the object is here uniform. How can we consider? Suppose a graph already is put before you in examination, okay, or in the book. How can we consider that the object is in uniform motion? Because we should take, suppose to prove this, we should take time. And at what point this graph shows? According to this point, we have to take the distance. Now in second, we take distance as 20. And we see that from origin to here, the time is 1 second. From here to here, it is also 1 second. Correct? So on the second point, it covers 20 meter. That means it covers 10 meter only. So its motion is uniform. And if the motion is not uniform in any case, then that will be the same graph just I plot here. Okay. And if suppose such type of graph is coming, then what do we observe here? In a certain time interval, suppose 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds we have taken. And here the distance is according to the previous one, 10, 20, 30, 40 like this. Then as we see that in 1 second it covers suppose 10. In 2 seconds, see here. What is the meeting point? It does not cover here 20. Means there is no, motion is not uniform, because in the mean interval of 1 second, it covers more than 10. That means non-uniform motion. Non-uniform motion. Okay. So in such a way, just we will have to revise the lesson and do our work. This is the, now a speed and direction. I taught you at present, how can we define a speed, rate of change of distance, a speed. Regarding the definition of a speed, just we will have to write here rate of change of distance is called a speed. Correct. Now, the mathematical formula of speed, that is distance by time. Correct. Now, unit of speed, CGS unit is, what will be the CGS unit? Its CGS unit will be centimeter per second, and its SI unit will be meter per second. Okay, meter per second we have to write. So in such a way, it is a speed. It is a scalar quantity. It is a scalar quantity. Means a scalar quantity is that quantity I taught you earlier, that the quantity which has only magnitude. Suppose just we write here a speed of any object, suppose it is 10 meter per second. So this is the quantity. Correct? This is the quantity and this is the unit of that very physical quantity. Correct? Now, the speed is a scalar. Means it has only magnitude. It has no certain direction. Whereas velocity is vector quantity because it is defined as rate of change of displacement. And as we know that displacement is a vector quantity, is called velocity. Correct? The same thing, just we have to write here velocity equal to displacement by time. Unit will be same. It is a vector quantity in this case. In this case, just we have to write here in place of a scalar, here we have to write vector quantity, because as we know that vector quantity is that quantity which has magnitude as well as direction. It is a vector quantity. Correct. Now see, dear students, just you will have to read the chapter according to the syllabus only, and each and every point I explained through the video. And the next point is average velocity. Next point is average velocity. Average velocity or speed, whatever it is, both are same. Okay, just we will have to take here. Generally we take velocity and speed similar, but there is difference regarding this, that it is a scalar, speed is a scalar and velocity is vector. Okay, average velocity, that can be defined as, see here, initial velocity plus final velocity divided by 2. Because as we know that while finding the average in mathematics also, number of quantity, how much, the first velocity and second two velocities are here, that is why we divide here by 2. If 5 velocities of objects are given, naturally we will have to divide it by 5. So in such a way we do it according to this and wait for the next one. Okay, whenever just I teach you, you will have to learn each and every day. And just I start live class also for the 9th, 10th and other standards. Okay, if you need, just you will have to do on the channel.